putting my hands in pH 7 liquid.
7? That's not too high. That's a lot bigger than like 0 or 1.
I know. I'd be much. Well, I think I should. Look at my hand. It's like
wet.
clean and wet. Yeah. Oh, I thought pH like 1 was good and 7 was bad.
No.
Because it's like a scale from 0 to 14, so it's like 7 should be really bad.
No, 7's the middle.
The middle?
Middle.
Well, then it should be
the middle.
Still the middle. I mean, is the middle better or worse?
The middle is the middle. Middle's water.
Oh, so it's just water. You see, today we're going to talk about pH and pOH, and yeah, that's what we're going to talk about. And we're going to actually learn that the extremes of the pH scale, 0 and 14, are bad.
Yes.
The middle, 7.
Yes. So just because the number is higher doesn't make it
worse.
Better or worse. Yeah, my son is hilarious. He's 4.5.
4.5, yeah.
And he thinks
not
that
7.
No, 4.5. He thinks that if something has a bigger number, it's better. So like he has a little race car that has a 9 on it, and he has a little Lightning McQueen with a 95, and Lightning McQueen always has to win because his number is 95, and 95 is bigger than 9. So
well, that's what I was thinking.
Obviously, it has to be bigger and stronger.
There you go. Okay, so, hey, we have a pH scale, okay? So if you look at the pH scale, if you've got a 0, that's not good. That's like battery acid, actually, less than battery acid.
Less than battery acid.
And then lemon juice is 2.5, it looks like. Vinegar is 3, milk is 6. The
so,
neutral water, that's 7.
Right there at 7.
But then you get to nasty stuff up at 14 in junk. Yeah, that's really bad.
Sodium hydroxide solution.
Drano.
Yeah. So 0, very low pH. You can even have negative pH.
Yes, you can.
And we're talking really concentrated acids that you want to be very, very careful
Don't mess with that stuff.
And then really high pH, we're talking really, really strong bases. You want to be very careful with those things as well. And the closer you get to 7, the closer you're out of water.
Yeah, so the middle of the road is good for pHs. Yeah. All right, pH, you probably have heard of pH.
Clean up your mess here.
Yeah. So, the pH, you've understood pH before, but here's the key thing. pH is actually a mathematical equation. And so you need to write down this mathematical. pH is actually the negative log of the hydrogen ion concentration. So, log? What the heck is a log?
Logarithm.
It's a logarithm. Now, if you don't know what a logarithm is...
It doesn't matter.
Yeah, because it's like a button on your calculator.
It is. That's how we're going to use it in here.
Yeah, but, I mean, there is important things to understand about logarithms and mathematics, and if you haven't gotten to logs, there's a button that says log on your calculator. So, it's actually a base 10 thing. We should probably briefly say one thing. If you go from a 1 to 2 to 3 on a logarithmic scale, this would be like, let's get this as a 1. 2 is actually 10 times more.
Yep.
A 3 is 100 times more.
Yeah.
A 4 is 1,000 times more. And actually, since this is a negative log, it's actually kind of the reverse.
Yep.
It's like this is 1, and this is 10, this is 100, and this is 1,000.
Yeah.
So because it's a negative log, it goes kind of backwards.
Yeah. We just had there was just an earthquake yesterday
down
in Baja, Mexico.
Which was a 7.2
It was a 7.2,
yeah.
Now, an earthquake that's a 6 and an earthquake that's a 7...
Say 6.2.
Okay, 6.2 and 7.2. That's actually 10 times stronger. The 7.2 is 10 times stronger than the 6.2.
That's right.
Because it's a logarithmic scale. The Richter scale is.
Okay, yeah. Actually, Mr. Sams, it's not actually 10 times stronger.
No.
But in the earthquake world, they play the game a little bit different. It's still logarithmic, but actually for each factor, it's 32 times more.
Oh.
I didn't know that until I was teaching a unit on earthquakes just this year.
And I don't teach earth science.
And
I actually know very little about earth science.
Yeah, so I was learning that. Hey,
cool.
This is a whole
stand corrected.
Bunch of equations.
Yeah. Hit pause,
Yeah,
print this,
this,
and or write them down.
Yeah, write them down in your comp book. These are like critical to understand how to do all this
By the way,
stuff.
if you're watching this in QuickTime, if you hit pause and go to File, Print, it will print that picture that's printed.
That's
there.
correct.
That's right there. So you can print that out and paste it in your comp book.
And we're going to use these big time
A lot.
in just a minute. So
Yep.
pause. Okay, we're back. Unpaused. All right, so let's take a look. This is kind of the key thing we want to learn in this podcast, is that if you have, now actually we should talk about this brackets. When I say brackets around H positive, we kind of learned this in Unit 9.
Yeah.
That means concentration, and that's in units of molarity.
Yes.
So if I have a concentration, now these do not have units. pH, by the way, has no units. No units on pH. Now to do this, folks, we're going to need to get our calculators out.
Okay.
So everybody needs to get their calculators out, and then we're going to start working with this particular table, and we're going to fill it in. So we're going to use this table and these equations and your calculator to make this all work. Okay, so everybody get your calculator out. So let's do this first one, Mr. Sams.
Okay.
We have this first one. Here it is. You get the pin on. And we've got a hydrogen concentration of 2.3 times 10 to the minus third. So I'm going to just get a blank screen here. So my concentration of my hydrogen is 2.3 times 10 to the minus third molar.
Okay, what should we look for first? Doesn't matter.
Well, no, but if you've given the hydrogen concentration, I would
Pretty
go
easy to
back
get
to that equation. The equation I would use would be this first equation here. Since I have the hydrogen concentration, I can just plug this equation into my calculator.
Okay.
So I'll say, pH equals negative log of 2.3 times 10 to the minus third. So here on my calculator, now you see the log button is here, kind of the fourth button up. So but I have to push the negative. Now, important thing, there's a subtract button right here and a negative button right here.
I want the negative.
It's the negative button. So I'll put negative log, and now this puts a parentheses right here. And now I'm going to type in the number, 2.3. Now, don't forget, of course, if you have an exponential number, you have to use the second function double E button and -3. Close your parentheses. Notice how this over here looks just like this over here, except for the little E thing. And then I'm going to push enter, and I get a pH of
2.64.
2.64. So that's the pH. So now I can go back to my table guy, and I can say my pH is 2.64.
Okay.
All right. Now there's something called the hydroxide concentration and also the pOH. So let's take a look here.
Yeah.
Now the pOH, actually the equation I like the best when we go to this stage, this is like super easy, the last one,
Yeah.
is pH plus pOH is 14.
Always and forever.
So if I say pH, I'll rewrite it, but I think plus pOH is 14. I already know that this number, pH, is 2.64. So that is simply 14 minus 2.64, right?
Yep.
And technically, I mean, sig figs,
Yeah,
that's 14.0. So I'll just say 14 minus 2.64. And I get a pOH of 11.6 or 36. And so let's put that back in my table. So this is 11.3. Oh, pardon me. Yeah, you're right. 11.36. And then my hydroxide concentration, I have to now find another equation to help myself out. Now, the hydroxide concentration, here is an equation that gives me the hydroxide concentration. It is 10 to the power of the negative pOH.
Okay.
So if I say 10 to the power of the negative, and the pOH here is 11.36, 11.36, that will give my answer. So I'm going to use, you see right there's this button, 10 to the x. It's actually the second function of the log button. There's a couple of ways to do this, but I think I'll teach them this way. Second function, 10, see it's got 10 to the power, and I'm going to negative, don't push the subtract button, 11.36, close parentheses, and I get an answer. Notice it's got that E in there, and I get 4.37 times 10 to the minus 12th. And that's the number that's going to go in my chart. And that's, here it is, 4.37 times 10 to the minus 12th. Now there's a last column right here. We haven't seen this. But this last column, what we want to do is we want to just say what type is it.
Is it an acid or
base, or neutral.
Well, I'm just going to look at the pH. That's probably the easiest way. pH less than 7, acid.
Yeah.
pH greater than 7, base.
Yeah, 0 to 7 is an acid. 7 to 14, that's 14, not 111, is a base. And so this is an acid.
Yep. Now, one thing we should say about these equations, don't get bogged down with how many of them that there are or what they all mean. Just look for an equation that gives you what you know and what you're looking for in that equation, and then just plug the one that you know in, and you will find what you're looking for by putting it in that equation. It's that simple.
Let's do this one right here where we've got
Okay.
4.8 times 10 to the minus third. So I've got a, was it hydrogen or hydroxide?
Hydroxide.
You sure?
Yep, positive.
Okay. So the concentration of the hydroxide was 4.8
8 times 10 to the negative third.
times 10 to the minus third. So what equation am I going to use to get something else?
Well, if we
let's do
have
this one. We haven't done this one yet.
Okay, that works.
This one's a little bit weird in that, but that's okay. So this is my equation right here. So I'll recopy it. The hydrogen times the hydroxide is 4.8.
Nope.
No, is 1.0 times 10 to the minus 14. Thank you, Mr. Sanders.
Always and forever. It will
That's
always equal 1 times 10 to the negative 14 when you multiply them together.
at 25 degrees Celsius.
Yes, exactly.
This hydroxide concentration is this number. So that's like, well, then H positive becomes X. So it's like hydrogen times 4.8 times 10 to the minus third equals 1 times 10 to the minus 14. Now, how algebraically you solve that problem, Mr. Sams?
Just divide both sides by 4.8 times 10 to the negative 3.
4.8 times 10 to the minus third then cancels here. 4.8 times 10 to the minus third. On the calculator, here, I'll clear it here, I'll say 1e negative 14 divided by 4.8 e negative 3. And kada bing, kada boom, I get the answer of 2.08 times 10 to the minus 12. Now, what's that giving me?
That gives you hydrogen ion
The
concentration.
hydrogen ion concentration. And that number then can put in this table as 2.08 times 10 to the minus 12.
Right.
Now, to get the pH and the pOH,
Just take negative log.
take the negative log. So let's find the pOH now.
Okay.
So the pOH, something we haven't done yet, that's the negative log of, well, the hydroxide ion
concentration.
And we knew the hydroxide concentration was this 4.8 number, right? So I'm going to take the negative log of 4.8 times 10 to the minus third. So, calculator, negative log 4.8 double E negative 3. About 2 point something, yeah. This is 2.32. That's the pOH. Remember, no units on
Right.
pOH. So I'll put this in the into the table.
Nope, wrong spot.
2.32. Yeah, Mr. Sams, I'm just right in the next box, and I got to look at what my columns mean. Now, this one I probably don't even need to do anything because pH plus pOH is 14, so I can just take 14 minus 2.32, and that's going to give me 11.68. So I didn't even need to go back to the other screen. Now, is it an acid or a base?
Look at pH. pH
Always-
greater than 7, it's a
Yeah,
base.
this is a base. All right, this next one's kind of interesting here because I just have a pH of 6. Now, I can do something real fast, Mr. Sam.
Yep.
6 and 8 is 14.
Yep.
That's 8.
That's
This is 6, so that makes it a acid.
Acid.
Man,
You're fast. I know the hydrogen concentration.
I do too.
1 times 10 to the negative 6. I win.
yeah, I know. So on this one, we don't need to go to 10 to the negative pH. Right? If you go back to the screen here, if you want to find the 10 to the negative pH, right?
Mm-hmm.
And so if I say 10 to the negative 6, I mean, you put that in your calculator. Another way to do this, but I'll show you another way here, so that might help you. If I say 10, and I use the caret button, and I type in negative 6, it says 1e negative 6. That's
Right.
the same thing as 10 to the minus 6, guys.
Right.
So this is 1 times 10 to the minus 6. And this will be 10 to the negative 8. So that's 1 times 10 to the minus 8. So we didn't even need a calculator.
No,
for
whenever
that.
you have whole number pH or pOHs that it's like 0.0, you can just throw that in as the exponent.
Yeah. I'm not sure we need to do this last one, Mr. Sams.
I think we're probably good. Let's
Yeah.
save their time.
Yeah, okay. I think
All right.
we're good. I think we want to talk about one more thing
Yeah.
here. So how do we know what pH something is, Mr. Sams?
Well, we can do it a couple different ways. We can use something called a pH meter.
yeah, and we'll be using
And,
that.
Yeah, and those are probes that you just put into a solution, and it gives you
A number.
and it tells you the pH. Another way is to do this using what's called a pH indicator.
Yep.
Now, some indicators, like this one says UI, that stands for Universal Indicator. It will tell you a very wide range, from 0 up to 12, what the pH is. Some indicators just change one color at a particular pH, and we'll also be using some of those. But simply, if you had a solution and you didn't know what pH it was, you put a drop or two of Universal Indicator in it, and you compare its color to the color that you would see here. And so, if it turns green, you're probably around pH 7. If it turns red, you're probably around pH 1. So it's an approximate way to determine what the pH is.
Yeah, and you'll be doing this in class. This is one of the labs/demos. You might even be doing it at home. There's some cool home stuff that makes this work too. So I think we'll just leave it at that. But there's a color way, and then there's a mechanical way using a pH meter. So there's 2 ways you can know pH. So that's the end of this podcast.
All right.
Okay, we'll see you in class, guys.